Welcome to the Myrna Method live stream. I'm registered Dietitian Myrna Haag. My goal is to bring you impactful nutrition information that can significantly change your life. And in this video, this is a life-changing one. It's about dementia, Alzheimer's, cognitive decline, and it's on an increase in our country. CDC says by 2060, Alzheimer's will be at a double rate than it is today. So in this video, I really want to give you the connection between diet and cognitive decline. And there is a huge connection. This video is going to be very sciencey, but I don't know how else to explain it to you without bringing all the science. So Sam, if you'll switch it down, let's get this thing rolling. So you should ask your doc for the APOE test. What is that? That is a marker that tells you your risk for Alzheimer's. So they call it the Alzheimer's gene. And I want to explain to you why this gene is super important and how diet is so related to the risk of not only cognitive decline, but also in relationship to this particular gene marker. So let's first talk about what is, oh, by the way, I had done a video on this before. If you've watched it before, this is going to be a deeper dive than what I've done in the past on the APOE gene. So I'm going to really get into some science and really show you all the pathologies involved in cognitive decline and how diet is related to it. So when we look at the APOE, what is it? What is the APOE? It is a protein carrier. It transports, it delivers cholesterol and fats throughout the body, particularly in the brain. So the APO lipoprotein E, it's a protein that's made in the brain by astrocytes, which are brain cells. It's also made in the liver and the kidneys and fat cells. The brain is the most cholesterol-rich organ in the body, and it depends on the APOE protein carrier to deliver cholesterol to brain cells. The brain contains roughly 20 to 25% of the body's total cholesterol. Almost all of this cholesterol is produced locally in the brain because the blood-brain barrier prevents cholesterol from crossing over from the bloodstream. Therefore, the brain needs to make most of these fats on its own. So that blood-brain barrier doesn't like a lot of gunk from the neck down getting into the brain because there's a lot of compounds that the brain can't clear. So the brain creates a barrier. And in regards to cholesterol, it needs to do most of the cholesterol making, delivering within the brain itself. Cholesterol fats are super important. They help create all the myelin sheaths in the brain. That helps with the synapses formation, creates repair for all these neuronal cells. Basically, it maintains all your brain cells. So super important. So the APOE comes in 3 variations. You have APO2, 3, and 4. So these are the different gene markers for the APOE. So you have this lipid carrier that's going to carry fats, lipid being fats. So you have a protein carrier, the APOE, that carries these fats through the brain in 3 variations, 3 genes. So there's 6 possible combinations because you get 1 gene from your mom and 1 gene from your dad. So that's why you can have a 2-2, 2-3, 3-3, 3-4, 4-4. So bottom line, the APOE, still a carrier, even though it's a different gene variation, but the APO4 has a mutation on it. Doggone it. Doesn't work like the other 3, or the other 2. So we're going to talk about that and why it's important you get that test to know if you're 25% of the population that may have it. First of all, the role of fats in the brain. 60% of the brain's mass is composed of fats, which play an important role in the brain, such as storing cellular energy, creating the myelin sheaths, insulating the neurons. So the brain is a fatty organ. We don't like to think of it that way because we don't typically think of fat in the brain, but it's very instrumental in the brain's functioning, which is a lot of times I'll hear on the internet, people will say, oh, a high-fat diet, the brain needs cholesterol. Let's eat a lot of cholesterol and eat a lot of fat. Well, there's no relationship to that, by the way, okay? It just is true that the brain is an organ that does require cholesterol, but it makes a lot of it on its own. So there's little brain cells that do this, the astrocytes, and we'll talk a little bit more about those. But these brain cells actually help clear out any toxic fats. So bottom line, even though the brain is an organ that wants fats, if it's not regulated for a certain amount, it can become toxic fats. And this is a driving force for Alzheimer's disease, which we'll get deeper into the science about that. Let's go back to the gene markers and talk about the population. The APOE2 is a good gene marker in regards to cognitive decline, Alzheimer's, because this one can actually provide protection. It's like a super APOE, does a lot of cleaning. It's just a really good one to have. But unfortunately, only 10% of the population has this gene variant. Most of the population has the APOE3, 65% of the population. You'll see a 3-3, maybe you see a 2-3. So if you're a 2-3 or a 3-3 or even a 2-2, you are doing great because those gene variants work like they're supposed to. But 25% of the population has the APOE4. Maybe they have a 3-4. If they have a 2-4, they could have some canceling effects there. But 25% of the population has one of those variants of the 4. And this particular gene variant increases the risk of late onset Alzheimer's disease. It's associated with diabetes and cardiovascular health. I'm going to really pinpoint for you how it's highly related with diabetes. I'm not going to have time to go into the cardiovascular connection, but in regards to the APO4 gene, if you also have diabetes, it's going to be double-fold of the damage it can cause. So let's get into the science, why and how. The APOE protein, once again, is synthesized in the brain. It transports and clears cholesterols and fats in the brain. The 3 variants, the 2, 3, and 4. It's produced by brain cells, the astrocytes, and the blood-brain barrier is a good thing because it doesn't allow a lot of gunk from the neck down to get into the brain. So a lot of this APOE transporting of cholesterols and fats is all within the brain. The APO4, on the other hand, is one that doesn't function as well as the others. What I want you to understand at this point, because there's a lot of science I'm bringing to the table, so I want to take one step at a time and make sure you get one concept at a time, because we're going to build upon these concepts. So it's important to understand the main point that APOE and Alzheimer's disease are related to a lipid transport. And the lipid transport is the APO4, the lipid transport that causes the highest risk is the APO4. In this particular study, they highlight the polymorphism, which just means a mutation in the lipoprotein E gene is a major risk factor for developing late onset Alzheimer's disease. Basically symptoms are seen after age 65. We kind of all know that. But here it talks about, and I'm going to give you the science on it, that the differences in the structure of the APOE isoforms influence their abilities to bind these fats, their abilities and how they deal in the receptors. And we're going to talk about a receptor in general that's the biggest culprit for this disease. And also the amyloid beta plaques, the scarring that forms in the brain. So right here, what I want you to get at this point in time is that the APO4 gene markers, the APO4 genes, have a mutation that they are not do as well at binding some of these fats or in the receptor areas in some of the areas in the brain, and they could also create more plaque in the brain. That's the APO4 gene type. It's going to have a higher risk in those areas. So let's break down each of those so that we understand it. So the APOE4 increases amyloid beta. And what the APO4 does is it increases the production of a protein called the amyloid precursor protein. And this protein is what increases the accumulation of the amyloid plaques. And the APO4s increase the likelihood of more of that precursor protein. Now, just because you have an APO4 doesn't mean you're automatically going to get Alzheimer's. Okay, it's not a great gene marker to have, but there needs to be a trigger. And that's what I'm going to move forward with. I just want to set you up at this point in knowing that if you have this gene marker and why it's called the Alzheimer gene, that it just doesn't function as well as the others. And in this case, it actually encourages an accumulation of a protein called an amyloid precursor protein that is associated with more scarring in the brain, because those proteins are what encourage the amyloid beta production, right? The plaques. And the APO4 is not as good at clearing those plaques as well. So in this study, it shows APO lipoprotein 4 enhances amyloid beta peptide production in cultured neuronal cells, which are brain cells. And basically what this study does is support the science that says that if you have the APO4, it actually stimulates this amyloid precursor protein. It doesn't do as well at clearing it, and this is what contributes to the scarring in the brain, which is the Alzheimer's. So if we move on, we're going to then talk about the APOE4 increasing the risk for insulin resistance. Now, this is, to me, the biggest culprit. This is the game changer with dementia and cognitive decline. Okay, you have the APO4. I get it. You're at greater risk. But where it becomes a line in the sand, because there's a lot of, like in Nigeria, though that population has a lot of APO4, but very low levels of Alzheimer's. Why is that? Because of the diet. So if you have the APO4, so you're not so good at cleaning up some things, maybe the transport of fats, they bind more, you don't clear out the fats from the brain as well, which can be a problem. But it isn't going to turn into Alzheimer's till we have some other factors. It's almost like the perfect storm. And insulin resistance, to me, is one of those perfect storms. I've talked about it in so many of my other podcasts because insulin resistance is truly at epidemic levels. People don't understand what it is, and they are eating the wrong diet. They're actually eating a diet that will encourage more insulin resistance and more dementia. But before we can explain the diet, I think it's good to explain the science behind it so it makes a lot of sense to you. So the APO4 variants, they actually bind to receptor sites, like that one study insinuated. So these little proteins tend to just clump on certain receptor sites. And the one receptor site it clumps on is the insulin receptor site in the brain. Now, this isn't going to make a lot of sense to you until I really dive into what insulin resistance is, which then I'll come back to insulin resistance in the brain, and then it's all going to connect. But at this point, I just want you to understand that when you have the APO4 variant, they like to clump around receptor sites. And when they do that, they disable them. They don't work like they should. So in the case of the APO4 and insulin resistance, It causes an impaired glucose transport. In other words, when it gunks up this receptor site, glucose can't enter the brain in the fashion it would like to. So let's talk about insulin resistance in general, and we'll come back to insulin resistance in the brain. Insulin resistance is really type 2 diabetes before they fully diagnose you. So if you have type 2 diabetes, you have this going on in magnitudes, right? So it's much greater. If you have insulin resistant, it means it's percolating. You may not even know you have it. So what is this insulin resistance? So biochemically, it's when you have a lot of excess fatty acids circulating in the bloodstream. So where do these excess fatty acids come from? They come from too much dietary fat, like olive oils and avocados and nuts and palm oils and even saturated fats, a lot of fats, excess. Now, although these are very healthy for you, there is a process in nutrition that we talk about a balanced diet. A lot of people don't know what that means. They're like, a balanced diet, I think I eat that. Well, you probably don't unless you understand what it means. So in regards to insulin resistance, it's from not eating a balanced diet, not eating the right percentages of protein, fiber, carbs, and fat, which we'll get back to later. Let's jump back into what is the root cause of type 2 diabetes and insulin resistance is a lot of excess fatty acids circulating in the bloodstream. They're going to come from a lot of excess, the big word, excess fats from your diet, or maybe you're just too fat. So when you have a lot of excess body fat, this also releases fatty acids. These excess fatty acids begin to accumulate in tissue that's not designed for excess fatty acids. Now, fats are designed for excess fatty acids, and that's really beautiful because they clump together and they form triglycerides. And fats that clump together in a muscle can also become triglycerides. But when they become excess, that's the big word, excess, they differentiate into a type of fat called a ceramide. These excess fats change, become a damaging fat, and these fats clog up the receptor site that insulin sits on. So what's up with this receptor site? As soon as you eat a carbohydrate like bread, pasta, fruit, you will release glucose into the bloodstream. So as soon as that carbohydrate digests, it releases glucose into the bloodstream, which is just blood sugar. And the whole purpose of glucose is to get inside muscles and to get inside certain brain cells, because there's certain brain cells that actually want the glucose. And muscle is dying for the glucose, really wants to have that carbohydrate. But the only way that that glucose is getting inside a muscle is when the pancreas releases the hormone insulin in response to all the glucose in the blood. Insulin rushes over to receptor site, sits on the receptor site, talks to a messenger who talks to another messenger, and allows a transporter to come to the surface of the muscle cell. And the same thing is going on in the brain cell. So insulin is the key that sits on this receptor site that talks to the cell and tells the cell to allow the transporter, the trap door, that then allows the glucose in. So the glucose goes in through the transporter into the muscle. What happens when you have a lot of excess fatty acids that have turned to a bad fat called a ceramide? Now, we think of ceramides in skin, and they can be positive fats. And a lot of times in the body, a lot of things, if they're kept in balance, serve a very positive purpose. But if things get out of balance, they are not going to be working for you in a positive manner. They become a harmful compound. And a balanced diet means that you're going to have balance everything else. So when your diet's not balanced, then it makes sense you're going to get insulin resistance, which means the insulin no longer works, the transporter never comes to the surface, and glucose begins to build outside the muscle cell, outside the brain cell. The glucose cannot get inside the cell it was designed to get in, to give you energy. Then what happens is all this blood sugar creates even more insulin. So even more insulin begins to surge through your bloodstream, and now you have a hog mess. You have a lot of insulin in the bloodstream, and you got a lot of sugar in the bloodstream. Not a good combination. But please, do not get confused that sugar and insulin are symptoms. The actual root cause of the disease is that the receptor site is clogged with too much fat. Don't forget that, because that's the root cause. Insulin and sugar are just the end result. What happens with this glucose is it then begins to dump in fat cells. And when you have insulin resistance, which a big part of the population does, and they don't know it, all they know is they can't lose weight, and every time they eat a carb, they swear they get fatter, and I'm not going to disagree with that. Because when you have insulin resistance and you go to eat a carb, well, guess what? Didn't make it into the muscle cell. It does seem to go more into the fat cell. You become a better fat storer. But the bad news is you get fatter, and that fat cell also begins to release more fatty acids in circulation, because that fat cell can also get damaged and have insulin resistance in the fat cell. Now, the fat cell's always going to take extra everything because they're storage containers, but they just don't function as well as holding on to their fatty acids. They become more loosey-goosey and release even more fatty acids in circulation. And then the bad news bears about all these ceramides is they also can leave the cells that they're attached to and causing damage and get up into the plasma, into the bloodstream, and cause damage in other areas like heart tissue and kidney. They can even create type 1 adult onset diabetes. So not a good thing to have. I did a really good podcast 2 weeks ago on ceramides, and you can just dive into all the health disadvantages of having these ceramides. But these ceramides are in excess when you have a situation of insulin resistance, when you have a lot of excess fatty acids being stored in places they shouldn't. So let's go back to insulin resistance in the brain, because after all, that's what I'm trying to drive home with this. So when we go back to insulin resistance in the brain, let me find that slide. Well, let's just first nail down insulin resistance, just so with it, we're not jumping ahead of the game here. So what is insulin resistance? It's when cells don't respond to insulin. So a lot of times people can read this because it's all over the internet, but they don't have a visual. And for me, I can read something, but I always have to draw myself a little picture so that I can actually see what it is I'm reading. So I'm showing it to you, the picture. Let's go into the definition. Cells don't respond to insulin. A condition where your body cells don't respond properly to insulin, a hormone that helps the sugar enter cells for energy. And this leads to higher blood sugar levels, and this forces the pancreas to produce more insulin. Now, if I was probably going to read that to you, it'd be a lot of googly gunk. But now that you have the visual, you can see from the visual, which I think is super important, that yeah, insulin is what allows sugar into the cell, but when it's all gunked up with these fats, because you didn't eat a balanced diet, or maybe you have too much body fat, you are now having a problem with sugar. And yes, you'll release more insulin in the blood. And the problem with releasing more insulin in the blood is you're going to be hungrier. And as a dietitian with my patients that have insulin resistance, it's really tough because I'm trying to really balance their diet. And I've got to really work in balancing the carbs. And I have my little program. I work with my patients. You can join my little membership program if you're listening to the YouTube video. And what I do is I help them understand how to balance the macronutrients properly. Because when you have insulin resistance, you still are going to need carbs. Muscles want them. Sorry, that's how muscles work. And if you don't do what muscles want, trust me when I tell you, they will send messages to the brain to eat more carbs. So when you have insulin resistance, it's almost like you crave the very thing that seems to turn into fat. It's just such a double whammy sword here. But unfortunately, they're giving you the wrong advice on diet. Because what they're telling you to do is eat a low-carb diet. Let's take all the sugar out of the blood so you don't have the insulin, so you're not hungry. Doesn't work, folks. Doesn't work. Because as soon as you take all the carbs out of the diet and you reduce the insulin, your doctor's happy, everybody's clapping. You did not solve the root cause of the disease. So it's temporary. It's coming back, and you're going to gain more weight. You'll lose a little weight, you'll gain a little weight, but bottom line, the muscles will tell the brain to crave more carbs. It's just how it works. It's the science on eating. It's the science, actually, on the body. Because muscles like glycogen. They want stored glucose. With insulin resistance, you're just not able to give the muscles what they need. So before I get too much on a tangent, I'm going back to the brain, because after all, that's what this video is about. So with insulin resistance in the brain, the insulin is not allowing certain brain cells that need the sugar to get access to the sugar. So certain brain cells are not needing the sugar that they desperately want. And to make matters worse, as these excess fatty acids differentiate, because they do in the brain, into a fat called a ceramide, these fats become more prevalent if you're an APOE4, because these little gene guys, they don't do well clearing fats from the brain. And so what can happen is they become more prone to insulin resistance. Not only that, these APOE4s don't clear a lot of fats from the brain as well as the other variants. They also contribute to the clogging of the insulin receptor site. And that's a real downer, because if you have insulin resistance and you have the APOE4, we need to get rid of insulin resistant, period. So in the case of sugar, everybody talks about, oh, too much sugar for the brain is bad. I'm going to agree. Too much sugar in the bloodstream is not good. But to get rid of it, we have a difference of opinion. As a registered dietitian, I'm looking at the science behind the macronutrients. I'm not really sure what everybody else is looking at, but I can tell you they're giving you a very short-sighted picture, because immediately they start talking about sugar and insulin. And I'm agreeing, don't like to have a lot of that in the blood, but we have to agree that's not the root cause. When you are not getting sugar in the brain cells, in cells that need it, then the sugar can actually go through the blood-brain barrier and affect other cells that don't need it. So this is getting a little sciencey, and I want to just take it one step at a time, because I know it's a lot of information. So I'm going to come back to that, but I want to really drive home the point that type 3 diabetes, okay, is Alzheimer's. And if you typed in your browser, type 3 diabetes, and on my screen, if you're listening to me and you're not seeing it, on my screen, I showed a browser where I typed in type 3 diabetes, which you can do yourself. And of course, AI now comes up with an explanation of everything. But if you look to the right of my little PowerPoint, you will see right there, Alzheimer's disease is a type 3 diabetes and Alzheimer's disease. So all over the internet, if you type in the right thing and you use some of the things that I'm telling you to use to put in your browser, you're going to be able to fact check me. So what is type 3 diabetes? Type 3 diabetes is exactly what I'm showing you here, insulin resistance in the brain. And if you're an APOE4, it's even worse, because you'll be more apt to have insulin resistance in the brain than if you weren't an APOE4. So let's continue on, because I'm going to bring you a little more science. I just want to bring home the point. When I talk about a balanced diet, what am I referring to? I'm referring to protein, fiber, carbs, and fat. I am not married to any diet, okay? Vegan diet, paleo diet, there's some benefits in either one. I am looking at what you need in regards to macronutrients. That's what registered dietitians do. We look at the science of food, we look at the biochemistry, and we try to bring it home for you. Now, if you have some clinical issues, I always have to do that caveat. As a clinical dietitian, yes, some of these macronutrients may be slightly different for you, or maybe a whole lot different for you, because you have a disease imbalance. And I have to really stress that. Epilepsy, there's a few I can name, that may mean these macronutrients will change in percentages. But the average population, which is like 95% of the rest of you, then a lot of this is going to apply. And I know you're on the internet and they're just acting like they can decide whatever these things can be. And unfortunately, that's really not the case. So if you are somebody that has a problem with glucose, you probably do have insulin resistance, but removing the glucose isn't the answer. It's knowing how to balance that diet. So let's talk a little bit more about insulin resistance. It also recruits other bad boys into the picture. And one of them is reactive oxygen species. And I'm going to call them by their science name. A lot of times I call them free radicals, antioxidant agents. But in research studies, which is what I want to give you so you can fact check me, they're actually called reactive oxygen species, ROS, and they cause oxidative stress. And here we go, the main culprit, insulin resistance. When you start getting insulin resistance and these fats start, causing a lot of problem in the receptor site, it's not able to tell the transporter to get the sugar where it's supposed to go because the message never gets through the cells, you're also going to recruit reactive oxygen species. Now, these reactive oxygen species in a normal amount are actually good. They're part of our normal metabolism, but it's in excess. And isn't it funny? I keep using that word excess because we're coming back to balance. Excess fatty acids, big problem. Fats are good. We need them. Excess is the problem. Reactive oxygen species, the body makes the right amount. Excess is a problem. What creates an excess amount of reactive oxygen species in the brain is insulin resistance in the brain. Okay? And these little compounds, they degrade brain cells. Another part of amyloid beta production. And these reactive oxygen species actually are in response to a lot of damage that's going on in the brain as well. So they can also, which is not so good, they can get into the brain barrier and cause a more permeable, they can cause your brain barrier to have what's called a leaky effect. We don't want that because a lot of toxins below the neck, right? We don't want above. So some studies talk about this leaky brain barrier, which allows toxins. It's the permeability of the barrier becomes compromised when these reactive oxygen species are forming. And how are they forming? What is the biggest culprit? Insulin resistance of the brain. I'm going to talk a little bit more about these reactive oxygen species. For some people, they're yawning because they've heard so much about it. But for some people, this is new information. And when you go to look up dementia, you're going to see oxidative stress everywhere. And you're probably not going to understand what that means. Oxidative stress is a big part of insulin resistance. When you have insulin resistance, you recruit these. You also recruit pro-inflammatory immune cells like tumor necrosis factor. So you've got these reactive oxygen species and these inflammatory immune cells all up in that receptor site, in addition to the APOE4, in addition to some of these other compounds, these ceramides. So you've got this receptor site just all gunked up. And this impairs glucose metabolism. Why is that? Because the glucose can't get to the cell it's supposed to. You have impaired glucose uptake. So I want you to understand these terms because this is what they're using out there in studies on the internet. So I want to be consistent with the language so that you can draw it back in your brain and understand how it implicates you, and most importantly, how we're going to prevent it through diet. So insulin resistance is a big part of this. And these reactive oxygen species are compounds that are created. And now we're going to talk about the ceramides. Again, another culprit of insulin resistance. How did the ceramide get there? What is a ceramide? Once again, in review, it's a fatty acid that was an excess amount of fats that differentiated into a type of fat called a ceramide. And these ceramides then can be very disruptive on insulin receptor sites. But ceramides can also damage neuronal cells. So you've got ceramides that can damage neuronal cells. I want to take back the home here when I talked about, let me go back. You also have reactive oxygen species that can damage neuronal cells, brain cells. So reactive oxygen species damage brain cells, and also so do the, let me find my other slide. That's what happens when I switch around slides. I can't get back to where I was. The ceramides also do the same. So ceramides increase amyloid beta. Elevated ceramide levels have been associated with vascular diseases, strokes, vessel disease. An increase of ceramide levels can disrupt the function of the cells, the vascular cells. It increases the permeability and the blood-brain barrier. And it basically can lead to injury in the brain. And this is a big part of what cognitive decline is all about. Once again, I want to keep bringing you back to what is the main culprit: insulin resistance in the brain. That is, if I had to bring it home to one area, and how it is going to be related to diet. So let me just take you to some studies. I always like to throw some studies in there. So ceramide signaling, an inherited multifactorial brain metabolic disease, okay? These ceramides are highly implicated in neurological diseases like Alzheimer's, Parkinson's. They also, when you have ceramides, most likely you're going to have reactive oxygen species. And now imagine being an APOE on top of this, right? So in regards to ceramides in Alzheimer's disease, in the key mediator, it's one of the key instigators of the disease. It induces, in this study, oxidative stress. It induces reactive oxygen species. So I wanted to show you a study where they actually used the word oxidative stress. And I want you to be able to think of the picture I drew for you of those little reactive oxygen species creating stress in these different astrocytes, in these different brain cells. And this is what creates the amyloid beta accumulation. This is that plaque in the brain. And when you get the plaque in the brain, that's when you lose brain function, right? Because you don't have the synapses from one neuron to the other, right? Because you have the scarring taking place. And in this particular study, it talks about Alzheimer's disease, the most common chronic progressive neurodegenerative disorder. It's characterized by extracellular deposits of amyloid beta peptides. Ceramides, the major molecules of sphingolipid metabolism, that's just the fat species they come from, and fat second messengers that has to do with the messaging of that insulin receptor site, have all been associated with Alzheimer's progression and pathology. So this talks about how the ceramides are directly related and drive one of the pathologies towards Alzheimer's. And once again, I go back to how diet is related to it. So if we finish this out in regards to where we are now with the brain, let me find my brain one here. With dementia, what you're going to find is the talk about poor glucose uptake. And where people get really confusing, I listened to a podcast the other day and it was like, oh, I just wanted to scream, because they were talking about if you have the APOE, you have really bad glucose uptake, so they were recommending a high-fat diet. But they weren't giving the listeners the whole science, right? They were just showing a lot of sugar in the blood and sugar in the brain in places it shouldn't. Let me just say this to you. If you get rid of insulin resistance, sugar is going to go where it should, okay? If you're at your ideal body weight and you're not eating a lot of excess food, you're not going to have a lot of sugar. To have sugar in your body is not a bad thing if it's working like it should. And that's the point I'm trying to make. So they're taking the poor glucose uptake, the insulin receptor site's disabled, the excess sugar then corrupts brain cells that are not designed for excess sugar. But bottom line, they're not giving you the full picture that it's a fatty acid disorder and that the excess sugar is a symptom of the major culprit of the disease. Insulin resistance, ceramides, reactive oxygen species, all of these degrade the brain. And now this slide shows all of that on top of the APOE genotype, which increases insulin resistance because it gets up there along with all the other guys, clogging the receptor site. It increases more amyloid proteins that actually create the amyloid beta. It actually increases lipid toxicity in the brain because the APOE don't help clear the fats. So these lipoproteins are responsible for delivering and clearing. So the APOE do not clear fat from the brain. So let's think about that, just common sense. I want you to put the common sense hat on, not the science hat, just the common sense, because we all have that one. If you have a problem with clearing fats, does it make sense that you're going to eat a diet high in fat, right? Obviously, common sense ought to tell you that no. High fat consumption causes an overproduction of circulating fatty acids, systemic inflammation, brain proliferation, which means a lot of these brain cells become damaged, and this promotes neurodegenerative diseases. And in this particular study that I'm bringing up, the study name, the title is Effect of High-Fat Diets on Oxidative Stress. Right there, because we went through this video, you're getting it. Because you know oxidative stress is coming from reactive oxygen species that are all bundled up because insulin's all corrupted in that receptor site. And this is all due to an excessive amount of fats in circulation. And this particular study brings all of that home just in the title, Effect of High-Fat Diets on Oxidative Stress, Cellular Inflammatory Response, and Cognitive Function. And this particular study talks about that they have done an analysis with several studies and that indicates that high-fat consumption causes an overproduction of circulating fatty acids and systemic inflammation. Immune cells, I talked about those. Those are the TNF, tumor necrosis factor. Immune cells, free fatty acids, which then we know turn to the ceramides, circulating cytokine, which are more inflammatory immune cells, reach the hypothalamus. That's the appetite center in the brain. And this can also cause problems with your appetite, just want to say. But the high-fat diet promotes this oxidative stress because insulin resistance in the brain does that. Insulin resistance in the muscle does that as well. But it's in the brain that we're talking about in regards to cognitive decline. So I think this slide really brings it home. Too much dietary fat is called lipid toxicity. Too much body fat as well. Excess fatty acids accumulate in muscle cells, and they disable the insulin receptor site. Now, I'm all for nuts, olive oil, avocados, all good healthy fats. But the key is we have to keep them in balance because even good fats in excess, even good things in excess can become bad things. So insulin resistance really is highly implicated with poor health, cognitive decline when you have the APOE genotype. So that's why I felt like this video was so important. And why wouldn't you want to know, right? Because if you are 25% of the population, then I'm never going to advise a high-fat diet, right? Doesn't make sense. So let's talk about how much fat you actually need. You want to take your ideal body weight, not what you weigh now. And you can multiply, or you can divide that by 3. This is going to give you approximately 25% of the amount of fat you need in your day. Now, most of the time, 25 to 35% fat is ideal. But if you have the APO4 gene type, as a dietitian, I'm recommending your fats under 25%. If you're a 4-4 genotype, it might be even as low as 20 or even 15%. Why is that? Because you're a double whammy, not good at clearing fats from the brain, and you're more susceptible to insulin resistance. I'm also going to really help you balance your diet so we can get you to your ideal body weight. So if you are trying to figure it out and you don't have insulin resistance or you don't have the APO4, then ideally you could take 25%, you take your ideal body weight, you divide it by 3, you could easily add 20 to 30 grams and you'll get your range. So the next question is, how do I get to my ideal body weight? So most people may know it, some people don't, but here's a formula we can use. For women, every inch over 5 feet, you're going to add 5 pounds and you're going to add it to 100 pounds. So if you're 5'4", that's 4 times 5 is 20. Your ideal leanest body weight is 120. You can easily add 10 pounds to that and still be well within a lean body range. For men, not much different. You're going to take 6 pounds for every inch over 5 feet, but you're going to add it to 106. So if you're 5'10", 10 inches times 6 pounds is 60 plus 106. Your ideal body weight is 166. You could add 10 pounds to that, 166 to 176. And you can take that number and you could apply that to some of the other macronutrients. Protein, we want to keep it at our current weight because we don't want to lose muscle mass where we're at now. This is about eating a balanced diet. Carbs, you take your ideal body weight and you multiply it by 1.3. And fats, which is what this video is all about, that particular macronutrient, and why it's important to keep it balanced and at the right level, you would divide it by 3. And fiber, minimum anywhere from 25 to 35 grams. So in summary, one of the things I wanted to make sure that really I drove home was that the APO4 gene is definitely tied into fats. And the fact that that has a mutation, doesn't do well clearing, has some other implications. So when you're listening to people on the internet talk about insulin resistance, having a problem with sugar, they're only giving you half of the science, okay? And the real whole picture is that it's a symptom of a disease. It's not the root cause. So understanding with Alzheimer's, there's a lot of moving pieces in here. And I really hope I explained well how they all work together and how we bring it all home with diet. Another recommendation for APO4s is to make sure you do take some good fish oil because some studies show this can be a positive effect. We want to avoid a keto diet, although I hear people talking about brain health. Why are they recommending a keto diet? Why does anybody recommend that is very simple. Because once you have the problem of insulin resistance, it does seem like reducing the sugar would definitely make a difference. And it does temporarily. A little caveat is once you have Alzheimer's, once you have the scarring, then you're not going to handle sugar well. And as a dietitian, when I have somebody with the diagnosis, knowing that they are already scarred up, I might be more prone to recommend a higher fat diet because they've already caused the disease. So having the Alzheimer's disease and giving somebody a diet with more sugar, we might see the symptoms worsen. Why is that? Because they have insulin resistance. They're not able to, they've got too much scarring, the damage is done. So looking at somebody with the disease prognosis, somebody who already has a disease, as a dietitian, is sometimes very different than when I'm trying to prevent the disease. So a lot of times the diet that prevents the disease may not be the diet I give you once you have the disease. Why is that? Because diseases are in imbalance. And as I said in the beginning, that's one of the things that clinical dietitians do. We analyze the balance in the person, where they're imbalanced. And yes, some of those macronutrients may change. Okay? This video is not about that. It's about preventing it. So the takeaway in preventing Alzheimer's disease, obviously, you should get tested for the APOE gene. Know your variant. Balance the macronutrients. It's about balancing your diet. Maintain a lower fat diet if you have this gene mutation. Omega-3 fats have been shown to show positive results. Maintain your ideal body weight. Remember, a lot of excess fatty acids in circulation can contribute to more insulin resistance. And an area I didn't really get into, I've gotten into some of my other podcasts, aerobic exercise helps because, I'll just throw this in, if you exercise your body when you're moving, let me take you back to the picture, when you move, it doesn't matter how bad you have insulin resistance, if insulin still can't get the sugar in the muscle, when you exercise, this is the only time this happens, the transporters in the muscle cell all come to the surface. That's a beautiful thing. Because if you have a lot of sugar in the blood and you have insulin resistance or you're a diabetic and the insulin's trying to help you get the sugar in the cell and it can't, as soon as you start exercising, you actually allow the sugar in the blood to get in the muscle. Okay? And that's a good thing because it can help reduce sugar out of the blood. So exercise actually does help because it helps with the symptoms of insulin resistance and diabetes. So I hope this helps. I'm always available if you're interested. I have a little membership, myrnamethod.com. On Tuesdays, all I do is work with members, teaching them how to eat a balanced diet. It seems simple. It should be simple, but trying to get the menus right can be sometimes confusing. I also have a book. It's been on the bestseller list in Amazon, Why Your Diets Fail and the Science That Really Works, which is what this was all about in this video. So, Sam, if we have any chats, let's...
Not today, but we do say our followers.
Oh, yes, we've got 900 followers. That's like big deal for me. So thank you so much. And it makes me work harder because when I see people are interested in the information, I want to deliver it even better for you. So thank you, totally appreciate it. Like and subscribe. And until next week, you can always leave comments. Let me know what you think. Totally appreciate it. Until next week, good to go? All right.